Hello everyone, so in this video, let us talk about a medium level problem from LeetCode. The problem name is Decode XORed Permutation. So the problem statement goes like this, that there is an integer array perm that is a permutation of the first n positive integers where n is always odd. Keep this in mind whenever you see highlighted word, keep that in mind specifically. So it was encoded into another integer array encoded of length n minus 1. Now this permutation of all the numbers is encoded into another array that is named as encoded of length n minus 1. Now what is there inside this encoded array? Such that the encoded of I is the permutation of I XOR permutation of I plus 1. So let's say that you have some permutation. I will directly take you some example. Let's say that you have some sort of a permutation. Now you take the XOR of, let's say, I and I plus 1 number and store it in the first position. The next to XOR, put it in the next position, and so on. So if this is of length n, this will be of length n minus 1. Now you are given this encoded array that is given to you. Now from that you have to finally find out back the actual permutation array, and it states that the answer always exists and it is always unique. Okay, that is the overall idea of this particular problem, that you're given some encoded array as you can see here as well. Okay, and then this is found by taking the XOR of let's say the first two numbers is this number, the next two number is this number, the next two number is this number, and so on. Okay, that is given to you. Now how can you solve such type of problem? So you have to first understand XOR and its properties to understand how we can solve around this problem. So what is actually given to you? First of all, let's take some properties into example. The first property is that if you have some numbers and if you take a XOR of all of them, the order doesn't matter. This is the first property. What I mean by this is, let's say A XOR, this is a symbol for XOR, A XOR B XOR C, let's say is equal to, let's say, capital X. Just take an example. So A XOR C XOR B. If I change the order also of these numbers and take these XORs, the XOR remains same. Okay, so this is one of the properties that you can remember of. The other property is that if you do a XOR of two numbers that is same, it cancel out each other. So let's say I have a XOR of A XOR B. Okay, and I have a XOR of B XOR C. If I do a combined XOR of all of them, which eventually means that A XOR B XOR B XOR C, these two XOR eventually cancel out each other, and it becomes A XOR C. So this term actually becomes A XOR C. Okay, these are some properties that you can remember of. Now, how can you actually solve around this problem? What is given to you? You are given these encoded numbers. Let's take an example of some random numbers. Let's say that the actual answer that I'm looking for is, let's say, A, B, C, and let's say D also. So as you can also remember is that the input array that is given to you is what you can say here. You are given the permutation of n numbers, and n is always odd. So if n is odd, the permutation array that is given to you is of even. So let's say I have taken an odd number. Let's say this is the permutation of first n numbers. These are the permutation. Now, what is given to you? A XOR B, B XOR C, C XOR D, D XOR E. That is given to you. Okay, now how can I actually use this information to find out? So if I somehow find out any of the number, let's say if I find out any of these numbers, then I can use that to find out the next number. Let's say I find out A. Let's take an example. If I find out A, then I can find out this position A XOR B. So if I do an XOR of A XOR B, so obviously A will get cancelled, because I've told you that if I take the same number, XOR it with itself, it will cancel. So if I take the first, let's say, encoded number, this is the encoded array. Okay, if I do XOR with A will cancel out, it will become B. Now I will know B. Then using the second number, I will know A XOR C. So I will XOR it with B, I will get C, and so on. So eventually I will get all the numbers if I somehow know any one number among them. Now, the first observation which I've told you is that if I know the XOR of all the numbers, it doesn't matter the order. So what you can do is that apart from this information, one more information that is given to you is that if I do a XOR of all the first n numbers, because I know that the n I have given to you. So let's say I have n equal to 5, which means that I have a permutation of 5 numbers. So let's say I do a permutation of all of them. That is A, XOR B, XOR C, XOR D, XOR E. Because n is odd, I know this answer, let's say, is equal to x. Now, in this, that is given to you encoded array. If I take every alternative number, A XOR B, C XOR D. So because it is odd, like I have taken all these even position numbers. So let's say I have taken like as a pair. So I have these pair numbers, like these pair XORs and the complete XOR. If I take these XORs and do a XOR with the actual this XOR, the XOR of all the numbers, these will cancel out each other. So A and B, I have A XOR B, and if I do A XOR B with this actual big number that I have, this A and A will get cancelled, because I've told you if I do a XOR with a number which has a component of itself, it will get cancelled out each other. Okay, now if I have C's or D that is here, if I do this complete number against C's or D, it will cancel out these numbers, and eventually whatever is left to me, because it is always said it is an odd number, I will always get at the last digit or the last value of the permutation I have as an answer. Now because I've got the last value, I can use this value to traverse back in the array from back to front and get all the values out. And that's it. You can just get all the values of this permutation. I hope you understand the logic part of how we are trying to solve this particular problem out. Let us try to learn more about it using the code. Now what we have done is this is XOR all variable that will use to find out the XOR of all the n numbers. Okay, so what I'll do is I'll iterate over all the numbers from I equal to 1 till n plus 1. Why? Because I have been given this encoded array that is of length n minus 1, but the actual permutation, the actual numbers are from 1 till n. So n plus 1, because this is of length n minus 1, so actual numbers are 1 till n, so n plus 1. So I will iterate over all of them. Okay, and just iterate over all of them and just like do a XOR of all these numbers. So I have now got the XOR of all the n numbers that I actually want. Now what I'll do is that I will now iterate over every alternative number in the encoded array, so that A XOR B, C XOR D, and E XOR F, and so on, so that I will remove out all of them from all XOR. So I will iterate over all the alternative number, that is like plus equal to 2, and XOR this number that is from the encoded array, XOR it with the again XOR all, so that all the numbers are removed from the actual XOR or, and the last number of the permutation is returned. So now the last number is the one that is remained after doing all this operation in XOR all. So XOR all now stores the last number of the permutation. Now I have that. Now I will make the final answer vector that will store all the permutation. So I will make an answer vector. Now I will push this last in this answer vector. Now I have the last digit. Now I will iterate over from the very last to the very front. And what I'll do is that I will take the last, let's say last number, and XOR it with the last encoded value. So whatever is the last encoded value, that is, let's say, so if I have A, B, C, the last value will be B XOR C, and because I have C, I can XOR it with B XOR C. C will get cancelled. I will get B, the next number. So I will take the next number and so on, and keep pushing in the answer vector. Now all these numbers are in the reverse order because they're traversing in from the back to front. But I have to print it from front to back because that's the array. Because I've been getting the answer from back to front, so I'm pushing it like this: C, B, A, and so on. But the answer actually is A, B, C. That is the actual permutation. Okay, so I have to in the end reverse the whole answer that I've calculated. You can also not, instead of push back, you can create a new array and like push in the front as well, like keep storing that as well. But it is your complete as wish that however you want to store the answer. And the end you have got the answer, you can just print out the answer. That's it. That's the complete logic and the code part for this particular problem. Let us now talk about the time complexity and the space complexity. Time complexity, this is for loop O of n, this is O of n, this is again O of n. So total time complexity turns out to be O of n only. Space complexity, as you can see, nothing is stored here. This is only constant variables, constant variable. This is an answer vector that is used to store the answer. If you want to take it as an O of n, you can take it just to store the answer, and then in the end you can just print out the answer as well. So it is again O of n for just storing out or printing out the actual answer. If we just want to print it out, if I just don't want to return it out, it will be O of 1 only. I can directly just print out as well. It totally depends upon your actual problem statement. And that's it. That's a complete logic on the code part for this particular problem. If you still have any doubts, you can mention on in the comment box of this particular video. I will see you in the next one, Decoding, and bye.